I figured it out. Hello and welcome to the Daily Space for today, September 17th. My name is Dr. Pamela and I am here to put science in your brain. I had a fabulous weekend and I hope many of you did too, because we got to meet face to face here in Edwardsville, Illinois, where we hosted the 500th episode celebration for Astronomy Cast, one of the sister programs of the Daily Space. Now, I know some of you are listening as you're on your way home from this trip, and some of you are probably like me, suffering from, well, what I'd best call conference hangover, that point where you are exhausted but deeply miss everyone that you got to spend time with. Now, while we were able to step out of our day-to-day lives and celebrate science for a couple of days, we celebrated what existed, and the march of science has continued on, and we have new information in some cases that we didn't have, well, or at least didn't have published a few days ago. Now, my first story for the day, as you can see in this image here, is one that involves brown dwarf stars. This is an artist's rendition of the system Epsilon Indi, and this is being shown the B and C stars in this system. This particular planetary system consists of two tight brown dwarf stars orbiting one another with the center of mass between the two stars, and then this set of two stars is then orbiting another star in the system that is a sunlight star. Now, because of the nature of this system, the way it's aligned, the way we're able to see all three of these objects moving on the sky, it's been possible for astronomers to calculate the masses of the individual components of the system, as well as measuring the brightnesses of the individual components. What this has taught us is, well, based on how faint these two brown dwarf stars are, it looks like they were never able to light up with the kinds of nuclear reactions that say this is a star. So, as near as we can tell, these two objects, they aren't planets, but they don't have ongoing burning taking place. This means they're brown dwarfs, not red dwarfs. Now, that line between things that burn and things that don't, we'd thought that it was probably between 70 and 75 times the mass of Jupiter, or about 7% the mass of the sun. Now, if these objects both appear to not be, well, happily glowing illuminated stars with nuclear reactions going on in their cores, that tells us with their mass measurements of roughly 70 and 75 solar masses, 70 and 75 Jupiter masses, that the cutoff for something to be a star must be higher than we'd previously thought. This is kind of interesting in terms of just how close we are getting to being able to measure exactly where something stops being not a star and starts being is a star. Now, as we find more and more brown dwarfs, as we find more and more small red dwarfs in binary and triple systems like this, we'll be able to measure more and more of their masses, more and more of their luminosities, hopefully get more and more of their distances with Gaia, and eventually go, this object at 78 Jupiter masses, at 7.8% the mass of the sun, this object is a star, this object isn't. So we're honing in, but we're learning our theories. Weren't quite right. So we're going to have to nudge up that limit. This is one of the amazing things about the science we're able to do today. As we get so many different surveys going on, as we have so many new observations coming in, each new observation helps us narrow in and understand exactly what's going on by eliminating some theories and opening up the doors for others. Now, moving on to something a little closer to home, I have a story of cryovolcanism and an icy little asteroid. Back when Dawn first got to the asteroid Ceres, there is this amazing moment of what the expletive is that, as we discovered this super shiny spot on Ceres. It was argued over whether this was salts, whether this was water ice, whether this was something weird we had never imagined before, whether it was aliens. It is never aliens. That is never the correct answer. Well, in new work done by Michael Sorey and Hannah Seisman at the Planetary Science Institute, they have gone through and they have studied that one super bright, beautiful, very pointy mountain that we see in the top of this image. That is the youngest cryovolcano that we know of on the surface of Ceres. This particular mountain gives us an idea of what a young volcano on Ceres looks like. It's called a Huna Mons, Mons being the word for mountain if you're on another world. Well, having seen this, they went looking to see what other volcanoes could they find. In this case, extinct volcanoes are what they're looking for. If you look at this image, what you'll find is we have craters with dark shadows on the upper edge and bright sunlit sides on the lower edge. This means that if something goes downwards, we expect light towards the bottom, shadow towards the top. The opposite is true where we have hills, and you can see there's this set of hills where we have shadow on the bottom and brighter on the top side of the image for these objects. Well, Michael Sorey and Hannah Seisman examined this object working with other collaborators as well, and they were able to identify 31 of these mounds, hills, former cryovolcanoes on the surface of Ceres. For 22 of these, they were able to make detailed observations of the slopes of the sides, and using the model from Hunamans to figure out exactly what a new pointy, sharp, just formed volcano would look like, and understanding the physical properties of Ceres. They modeled out how long it would take for a volcano to slump down and flatten into the surface and become rounded and more rounded and eventually fairly flat hills over the fullness of time. This allowed them to figure out that the asteroid Ceres probably on average produces roughly 10,000 cubic meters of material per year on its surface via the cryovolcanism processes. These domes have been forming over the past 1 billion years. This is a world that is alive, that is active, that is still geologically changing, and this is not what anyone really expected from an asteroid. This is a very cool and novel result, and I hope that we're able to get back in the not too distant future and do further observations to figure out just what all is changing and start to figure out the ages more accurately, perhaps using crater aging like we do over at CosmoQuest.org to figure out the details of all of these volcanoes. Now, continuing on our observations of the solar system, we have news that new explorations are going to be possible. As many of you know, when the InSight mission launched a few months ago, it had 2 tag-alongs. These are the Mars 1 A and B suitcase-sized CubeSats. CubeSats are satellites that are built out of a specifically sized cube, and these cubes can be configured in different numbers to build increasingly larger missions that, well, it now turns out can safely go on, well, at least beyond Earth journeys. We still have to wait and see what happens when InSight gets to Mars in November. The hope is that Mars A and B are going to be able to follow InSight down to the planet in terms of listening and communicating. They're going to remain in orbit around Mars. Now, this is testing, can we build little tiny low power, well, I guess low energy to get there because they don't weigh very much, satellites that can act as our well, ears for what's going on down on the surface of these distant worlds. So far, everything is looking good, and in hopes that we have found a new and amazing and low-cost way to explore our solar system, NASA's Thomas Zurbuchen, this is the Associate Administrator of the Science Mission Directorate, is announcing that they're going to put forward $100 million worth of funding for SmallSat science missions each year. This starts to give us new ways to dream up exploring our solar system. So maybe getting a new mission out to, well, Saturn isn't that far in our future. We just need to think, well, think very, very small. Now, not necessarily scientific news, but an answer to a what the expletive is going on in New Mexico finally came out earlier today. The Twitters lit up last week as the Sunspot Solar Observatory out in New Mexico near the city of Cloudcroft suddenly got shut down. And this is an observatory near where the Sloan Digital Sky Survey is observed. It's Apache Point. And Sunspot is a facility you see here in this image that has the large Richard Dunn Solar Observatory, which is this spiky bit in the background in this image, and it observes the sun day after day after day, looking at the disk. And for reasons that no one understood, the FBI showed up and asked everyone to please leave, and vast amounts of speculation raced across the internet, as always happens. People said maybe it's terrorists, maybe it's scientific something amazing, and maybe it's aliens. And did I mention the answer is never aliens? In this case, it turned out to be something fairly mundane. In a statement that was released by the Association of Universities for Research in Astronomy, it's been shared that the decision, and here I quote a press release that came out this morning, the decision to vacate was based on logistical challenges associated with protecting personnel at such a remote location and the need for expeditious response to the potential threat. The threat in this case was apparently there was an ongoing law enforcement investigation of criminal activity up at Sacramento Peak, where Sunspot is located. There is nothing in this press release that is saying this is a staff member at the observatory, that this is a scientist, or anything else. It's simply criminal activity in the vicinity. Sunspot National Observatory, or Sunspot, which is part of the U.S. Solar Observatory, is located up in the Lincoln National Forest. This is near White Sands National Park, and is an amazing facility to go camping and exploring. And while we don't know any details, it is my hope that this is simply creepers in the woods doing illegal activities that have nothing to do with our science. And this was simply a moment where the decision was made to, well, vacate the premises to make sure no one got caught in, well, anything that might have happened at the facility. So this is all we know. And it's always good to have a mystery, but let me just repeat again, it is not aliens. So we've had an amazing week from figuring out that, well, brown dwarfs that aren't glowing like stars can get to be a little bit bigger than we'd previously thought, to identifying rates of cryovolcanism on Ceres, to now knowing there's going to be $100 million per year for SmallSats to do science. Well, I think this is a pretty good roundup, and I'm going to end things here and take your questions. Now, while you go ahead and type those into the chat, please remember to @me, @CosmoQuestX. As always, I'd like to also remind you that this show is produced by the folks that also put together CosmoQuest.org. It's your place to go and learn and do science. We are a part of the 365 Days of Astronomy podcast series, and we encourage you, while you're listening, if you've got some screen real estate, go ahead, pop open a window and do some science as well. We have more worlds in our solar system and more data on those worlds than all the professional scientists in the world can fully process, analyze, and understand on our own. We need your help looking at existing NASA images to help us, well, pattern match where are the craters, look for the rocks, identify the boulders, figure out where is it safe to land, and where would it be really interesting to go and explore. We are a collaboration. We are currently led out of the Astronomical Society of the Pacific, working in collaboration with the Planetary Science Institute and Youngstown State University. So thanks, and I'm going to see what all we have going on over in the chat. So I see that Kmore is asking, so are there any future missions to go and explore the asteroid belt worlds? Yes, the OSIRIS-REx one is the one I'm most excited about because we're actually working with the OSIRIS-REx mission. This is a primarily NASA mission to go to the asteroid Bennu, pick up a rock. This is more of a grab and go kind of deal. We're going to mug Bennu for a rock and bring it back to the planet Earth. There is also the Japanese Space Agency JAXA mission to Ruga, I think is how you say it. And this is the Hayabusa 2 mission. So these are much smaller asteroids, but we're still out there exploring them. So Hanny's Verb is asking, could it just be the composition of these particular brown dwarfs that caused this? Yes, this is one of the things that we're still trying to figure out. We know that stars behave in slightly different ways evolutionarily, depending on what is their composition. When you have a lot of heavy elements in a star's atmosphere, the electrons are able to jump between a lot more different energy levels in these heavier atoms, and this helps the star cool off. That changes in small but not subtle ways how the star evolves. This can also change what is the maximum mass a star can achieve while it's forming. All of these things vary, and what we're going to have to do is over time build up observations of here are brown dwarfs with this composition, here are brown dwarfs with this composition, and red dwarfs, and look for that point where here we have brown and here we have lit up with nuclear reactions red dwarfs. So we're all going to have to figure this out over time. So Paranor is asking, with cryovolcanism on an asteroid, would it make it a potential planetary seed? Well, so the issue with cryovolcanism is all you're doing is taking what's inside the asteroid and putting it on the surface, and over time that slumps right back down. It's just sort of like our own planet Earth doesn't get more massive all because a volcano goes off. What ends up happening is we pull stuff out from inside the planet in one place and put it up on the surface, but at the same time on the planet Earth, where there are places where the various plates are converging together and we have one plate of land diving under another. Well, here we're recycling that material back into the planet. It's just a matter of recycling. Different worlds recycle their, well, bits and pieces in slightly different manners. So Larry is asking, are brown dwarfs really brown? No, not really. So this is just what we call them. They're dim, they're actually faintly red. And naming of colors is such a cruddy way to try and refer to these things. These stars all emit light in an entire rainbow of colors. This is called the black body spectrum. And while the majority of the light will come out, not the majority, while there is a maximum color of light that light comes out at, this is the maximum in this black body curve that is directly related to the temperature of the star. It's not like there's a color in the rainbow that is called brown. It's just as things get particularly red and cold, we call them brown. That's it. We just call them brown. So Paranor is asking, we'll clarify planetary seed since it has enough gravity for cryovolcanism, would it be a good gravity well to be considered a seed? Um, so here what I think you mean is, would during the formation of a solar system, would it have enough gravity to pull other things in and perhaps grow up to be a full adult planet? And here I just don't know. We don't know enough about planetary formation. We do know that currently in the asteroid belt there isn't enough material for it to coalesce into a planet. I think the better way to look at it is, we just have a continuum of sizes of objects, and the trick is to figure out at what point does the physics within the world, the geophysics in this case, start behaving in different ways. We know that really small asteroids tend to be these lumpy boulder covered things, whereas we look at Vesta and Ceres and we see differentiated mineralogy. We see all of these different cool processes taking place. It's more a matter of not planetary seed, but place where all the things that happen on planets are capable of happening because there's enough gravity. So Paranor is also asking for an update on the arm. I broke my arm a couple weeks ago. It still hurts. That's the best I can do. Still can't use it, which is frustrating. When you see me back at my regular desk, you're going to know that everything is back to normal. I'm not going to get a robot arm. I am starting to feel like a robot because I'm doing a whole lot of voice to text with my computer. Do we have any other science questions out there? Yeah, K-More, pain pills are a fabulous thing. That is true. They don't always do as much as they should. That's the sad part. If we have no more science questions, I'm gonna tell you what else you can expect this week. We have my collaborator Fraser Kane is off on a cruise with Dr. Paul Matt Sutter. So we aren't going to have Weekly Space Hangout or Astronomy Cast recording this week. We came out of hiatus and apparently we're temporarily going straight back in. Sorry about that, folks. But here at CosmoQuest, we're going to have plenty of content. As always, we're going to work to bring you the daily space, technology willing. We have had some Twitch glitches. Technology willing, every Monday through Friday at 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific. On Wednesday and Friday, Dr. Matt Richardson is going to be bringing you Astro 101 as soon as the daily space is over at about 1:30 Eastern. On Thursday, instead of seeing Dr. Matt, you're going to get me back with a guest who I don't know. I love that my staff surprises me with these things because they're more organized than I am sometimes. We're going to have someone in who works at the edge of, well, science and some other amazing career path, and talk to them just like we talked to Surly Amy last week about how she combines art and science. Other than that, Tuesday night, I'm not quite sure what we're going to be doing yet. That's usually when I hold office hours and code. Thank you for the bits, Checker Kev. I can't code with only one hand, so I'm not quite sure what's going to happen tomorrow night. I may take it off. But we're here for you. We're here to bring you science. So thanks for being here to take the science. And I see that AstroWise is sharing the link for Astro Tour, so that tells you where Fraser is now. A year from now, I'm going to be taking people on a tour of the American Southwest to go visit Kitt Peak National Observatory and the Canyonlands. If you want to go visit the desert with me, please check it out. This is my favorite part of the United States. If you've never been to the Canyonlands, it's like nowhere else in the world that I've ever seen. It's amazing geology, and Kitt Peak is, well, one of those places where I've built some of my best astronomical memories. So I hope to get to see all of you in the future. Larry's like, you need a grad student to help you code. They're already working on their own code. So thanks for being here, and safe travels to all of you that are still working your way home from the Astronomy Cast 500 celebration over the weekend. Look forward to talking to you more and giving you more science tomorrow. So wherever you are in the world, Have a fabulous morning, evening, or afternoon. And remember to, well, get outside and look up. Bye-bye.